And hello to the internets once more. Back in Turing Complete. Why? Because I'm boggin' well enjoying this game. It's fun. So we're going to try, and I won't say complete it, because I think that's asking for trouble. And get as far as we can. We've done all the way up through here. We have a working computer and have completed at least a couple of the software problems. That one's a fairly simple multiply by 6, as it turns out. Add 5, multiply by 6. That one, a little bit of reactive ifs and buts. Don't know what these two are just yet, but we'll find out in a second. Hello, hello, Michael. That did not make a sound at my end. I wonder why that is. That's probably it. Let's try one of these for a giggle. That's more like it. How's yourself, Michael? Life sweet? Everything going just fine, I hope. Alrighty. So, well, hey, Barbaric as well. Good to see you. How are things in the barbarian world? This is one of those big axe-wielding things with sort of like doom-laden barbarian-y nature. That's how it is. So yeah, we've got our first working computer. Up here, unsigned, signed, equality byte XOR. Oh my, the maze. We're going to be heading there, up to CPU architecture 2 via wide instructions. Wire spaghetti I do not like the thought of. Things go well in Barbarian World. Made a superheated nitrogen bomb. Revising some designs, but the crater was nice. A superheated nitrogen bomb. You got to clue me as to what the context is there, because I'm like, what? Develop your own CPU. Yes, indeed. If I hit this button here, we can have a look at the exact nature of that CPU. There it is. There's a single byte input line, a single byte output line, a chunk of RAM, well, a chunk of ROM actually, and knobs and buttons. Look at that, we've got 6 registers. Oh, Michael, look at that. It's fearsomely limited because I can only do things like arithmetic instructions on these 2 registers. I can't do anything. I can only load immediate values into register 0, which sucks. I can only do sums on registers 1 and 2, and they will only ever leave their result in register 3, which I can then do conditionals on. Mechanical explosions via creating the largest overpressure you can in as quick a time as possible. Ah, right. So what, you're dumping, I don't know, freezing cold nitrogen into a tank full of superheated nitrogen and seeing what happens? Oof, that could get messy. Take out your own entire base. And it sounds like a laugh. But of course at that point, says I, you want a high pressure tank full of superheated hydrogen, and you just link it to a tank of oxygen and see what goes on. That could go fun. Or nitrous oxide. That might even be more fun. Who knows? Anyhow, right. This is our current CPU architecture. It works. It could be shrunk down considerably, but these registers are stuck in place, or were stuck in place, and frankly, I think leaving a little more open work than trying to compress it down into a tiny little box is probably wisest. We've got a software problem to solve, 3 software problems to solve by the look of them until we can get to the next level. So, fun times ahead. 40 by 40 frames of base is gone, but that's what base is for. Oh my, that must have been a mess. Absolute complete kaboom. It's a lot of space. Security access door to the storage room is broken and keeps locking our janitor inside. Alright. This is Mr. Sausage Man, condescending little git who keeps setting me problems and tells me that if I don't get them right, he'll eat me. The door keeps changing the passcode. We need a program that can recover the passcode at any time. Well, alright. The easiest way to find the passcode would be to try all the combinations till you find the right one. Broken mechanism does make a weird beep when your guess is too high. You might be able to get that to your advantage. Alright. You win this level when you output the correct passcode. No output will fail the level. Additionally, the input will be 1 after a guess that was too high and 0 otherwise. Alright. So, assumption. Well, I've only got 255 possibilities in this. I don't have a shift capability, so I can't divide by 2. It's an arse because I'd really love to do that. I can think of a really simple program to do this. Hey, Butts, how you doing?
Isn't that nice for you?
All right. So, if we assume the passcode...
Oh. Hello, handsome.
Oh, Butts, you flatterer. How are things in Buttsmutt's world? Did you have a lovely evening talking nonsense with Snow? Right. Okay. So, this gives me a 1 when my input is too high. That's cool. So, if I start at 255, subtract the input, I will automatically find the passcode. So let's try that. Okay, it's programming time. Bin this lot. 255, 266, nearly. Right, that'll load that into register 0. Into R0. I can copy from 0 to 1. Label a loop. Alright. So. Right. How do I do this? Yeah, everything is okay in the Butts world, or better apparently. Oh my, that's cool. Life is sweet. Okay or better has got to be it's got to be one of those good things, right? So I can go out 1. I didn't write out 1. Okay, so I need to add a new opcode and I need to invent the new opcode. It's copy from register 1 to the output line. There you go. Why can't I just add an opcode from here? It'd be so much nicer if I could do that. Out 1. Okay, done. Oh, in 3. Now I need to in 2. Sub 1, 2, because that's how it works. Compute. We had a new opcode again, adding opcodes left and right.
Coffee.
Thank you. Hi, Alfie. How you doing?
Coffee.
Must admit, it amuses me that sub is 69. Well. Okay. So I've subtracted my input value, which is either 0 or 1, from my value in what used to be register 1. I'll leave it in output 3. So if I then copy 3 to 1, loop BNE. Right, that there stuffs the value of loop into register 0. Branch not equal compares what was in number 3 and jumps to loop. Hey Leroy, I see you. How you doing there? Alright, you guys go out of the way. Derp. So, what is going on? Ah, there we go. Okay, that did not work. Why not? Where's my registers? Where are my registers? That's annoying. Copy 0 to 1. Right, label loop. Out 1. Ooh. Bottoms. That doesn't work, does it? I can only copy 63 in there. Ooh, I wonder. How about I do that? With 0, 2, and then sub 1, 2. That should leave 2, 5, 5 in 3, and then copy 3 to 1 SPY. That's a CPY. All right. Dota is here. Is this BBC host Mr. Duke feature? Oh, I've left it on the bleeding news desk again, haven't I? Here we go. That's more like it. Sorry about that, everybody. Yeah. Very slow news. Derp. Hi, Skurrus. Yeah. So I'm too eager to get into the actual programming and the wires and everything. So much more fun that way. Talking to you lot. Just sitting there going, oh, my chums are over here, and my game's over here, and I'm having a lovely time. Yeah. Okay, so 0 into R0. That's not what we want. Copy 0, 1, 1. Copy 0, 2. Right. So 0, 1. Am I actually getting any values in there? Yeah, there we are. I can look at how things are working there. Copy 0 to 2. Subtract 1, 2. That should leave me 255 in 3, which it does. Copy 3 into 1. It's already in there. I've just done it, right? Okay. Out 1, 255. Yay! Right, that's better. Into now, is that counting? Is that going to count as -1, or is that going to count as 255? Oh, 254. So that's good. 253. Yeah, all right. We're doing as it's supposed to do. I could do a whole bunch of clever stuff here with starting at 1 and adding it to itself until it doubles and then halve the result, but...
Third place? What the heck were you thinking? Nah, I'm kidding. Third place is pretty damn cool.
Nice, Blinkster.
Oh, hello, handsome.
Oh, and you're flattering me as well. Oh no, what will I do? Life is so harsh. Okay, so that was a bit slow because it literally rippled through every damn passcode. I don't care, it worked. What's this one here? The length of our week is 4 days. Our week named 0 day, 1's day, Tuesday, and 3's day. Fine, whatever. Sim Earth numbers their Tuesday incorrectly. Yeah, fine. New Year is coming up. We want you to calculate the weekday of everyone's birthday. We will give you the date, and you have to return the weekday within 8 ticks. Right. That's not awful. Calculate modulo 4 of the input. Yeah, absolutely. So I need to AND off the 2 bits at the bottom. Now I have an AND instruction, so that's not too terrible. In this level, you're given a number as input, and you should return that number modulo 4 as a result. Challenge: you have only 8 ticks to output the desired result. Don't need to change your hardware. Don't figure it a trick to do. It's an AND. It's not a trick. It's just fine. Okay, fine. So, 4. Copy. Actually, 3. Copy 0 to 2 in 1. And 1, 2. Did I make one of those? No. Here we go. Assembly code, instructions, compute. Was it AND, NAND, sub, unused? Randomly add these things together. There we go. And 1, 2. All right. Check, check. Save that. You two bugger off. Out 3. So I've loaded a 3. I've copied it to register 2. I've taken the input into register 1, ANDed them together, kicked it out. I don't see what the problem is. Maybe that's just it. Right. Yeah. So I've used 5 of my ticks. Okay, fine. Ching, 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 ching. Aha. Architecture. Next. The maze. Oh my. Right. The fabled maze. If you solve it, you win the competition. Well, goody. Write an algorithm that gets the robot from the start to the exit. This level is hard. You want to write down the pseudocode for your algorithm before you implement it. Nah! Remember, you can't use immediate values larger than 63. Why would I want to? Common mistake is to try to jump to a label further down than the 63rd byte. Whoa. Okay. Alrighty. So, what do we want to do? What kind of maze is this? It's not an evil maze. It's a maze that we can get out of by following either the left hand or the right hand wall. Left hand wall's a lot quicker. Our robot is seeing a number 1 for a wall or a 0 for nothing. Okay. Can't walk backwards. So basically, I want my robot to walk along as if he had a hand on the left-hand wall at all times. So that's cool. He steps forward. He looks to the left. If there's a wall there, he goes back to the right, steps forward. Looks to the left. If there's a wall there, turns back to the right, steps forward. Yeah, or the right hand wall. The only reason I'm going left hand wall is by this particular maze. It looks like the door is closer on the left hand side. Although there's a thingy on the wall over here. There's coins as well, which I frankly don't care about. You see, there's the whole notion of ethics here, Dota. Just because we can doesn't mean we should. Oh. Damn it. What the hell happened there? Robot teleported. Right, laser's not going to be a lot of use. And I can only see one dot in front of me. So, okay. If I can move forward, I should move forward. Turn to my left. Repeat. If I can't move forward, I should turn to my right. That's about it, actually. Try again. If I can move forward, I should move forward. If I can't move forward, try again. If I can move forward, I should move forward and turn to my left. If I can't move forward, I should turn to my right. That's it. That's the whole bloody algorithm. Right. Okay, we're doing this. So, in 3. Right. Label loop. Label forward. If you do the if I can't move forward, I should turn right, you'll get myself stuck into an infinite loop. Alright, that's what have I missed? I can't move forward, I should turn right. Now I can move forwards. Okay, but tell me about it. What am I missing? The next corner. Alrighty. Alright. So, chonk, 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 chonk. If I can't move forward, turn right. I can't move forward, turn right. I can move forward. I see what you mean. Right. So it's not so much an infinite loop in the robot, it's an infinite loop in the maze. Oh, hang on. Yeah, right. So I've got there. I can move forward, but my implicit part of moving forward is to turn left. So it's move forward and turn left. So I would, in this particular case, automatically go, right, I can move forward here, move forward, turn left. I can't move forward, turn right. I can move forward and turn left. I can, yeah, so I can move forward and turn left. Hey, Snow, how you doing? Gonna blow you kisses as well. Mwah. Mainly because you're making Buttsmuts happy, and that's a fine plan. But you should also be happy. Are you happy? Are you happy and you know it? Could you clap your hands? Alright, I gotta try it. I'll give it a go. Right. Ugh, that didn't work. Forward. BQ. So if I if 0, let's call this forward and left. Can't remember how to drive the robot. Manuel the robot. 1 for move forward, 0 for turn left. Okay. So 1, out 0, 0, out 0, loop, jump. Okay. Snow is in fact happy. Oh yeah. Trying to find a matching AM transmitter for a receiver you bought today. Ooh. What's your general frequency range? Are you actually trying to find a specific one? Because I'd have thought you'd get hold of a transmitter and just tune it. But maybe I'm missing out the plan. A 40 megahertz. So it's his automation transmitter. Right. Last. Turn right is a 2. 2. Out 0. Jump. Loop. Jump. Alrighty. Scale models of cars. Yeah. Yeah. Well, I'd go model shops, but you know what you're doing. Way more than I do, I suspect. I would hope. Right. So he can't go forwards, so he should turn right and go back to the loop. Can't turn forwards, so turn right, go back to the loop. Now he can go forwards, so that should go forwards and left. Forward 1, turn left. Alrighty. Can't go forwards because there's a wall. Turn right. I'll give him a couple of corners. See how the poor fella does. Right. So he's going to go down this little dead-end alleyway here. Oh. Oh, look at that. A coin. He won't step on a coin because a coin is a number. None of them are blocking the path. But he's not going to collect any of the coins unless we tell him to. So 0's easy. How do I compare with a number? I have to load that number in, subtract it, and then if it's 0, then I can deal accordingly. So, what is a coin? I can't read that. Is that 8? I honestly, seriously cannot read whatever that number is. Can I compare to the wall instead of the path? Reverse the logic. Yeah, looks like an 8 to... Yeah, good out, right. Yeah, that wouldn't be a problem. So I would basically say if non-zero, turn right. Otherwise, forward and left. No, that still would work. I couldn't just compare with the wall. Oh, I could compare with the wall, but the wall is a 1. So what I need to do is say if it's either a 0 or an 8. Oh, hang on a minute. Oh, yes. What we can do, of course, is and our result with 1. Because we've either got a 1 or an 8. So if I pull in the value and it with 1, it's a wall. Yeah, the thing is there, but that would work, but it still wouldn't get me. I'd have to deliberately compare with a 1 rather than just saying 0 or non-zero, which is my simple compare. The annoying bit is having to turn just to check the wall. Good God, yeah. Would be nice if there was a sensor in the left and right as well. The exit, I believe, is this fella here. Looks like an exit to me. If I have to press the green button to get there, I've missed a trick, but the guy hasn't mentioned anything about that. The exit, yeah, you might be right. If the exit does not show up as a sensible number, like it shows up as 33 or something, all right, let's go and have a look. Door. Well, that's a dick move, isn't it? Yeah, render I did see. I'm going to be enjoying fiddling with that, although I'm not quite sure what the cable channels gubbins is all about. That's going to be a laugh. Oh. Well, okay. So door is 3. Great. Fine. You're just going to cause me fuss and bother, aren't you? So I can basically, as Butts said, treat anything that is not a 1 as traversable. I'll carry on from there. Yeah, crazy Leroy say if you followed it, the cable channels allow you to go beyond your current network and address networks via another device. Yeah, I've got to do a good read because I'm just like, yeah. Yeah, I honestly have not understood the syntax in there to say what's going on. Got to give it a good sniff and find out. Not sure what it's for though. What's the actual use? Hey ho. Right. Okay, so what am I trying to do? All right. So let's set this up to compare with a 1. 1. That'll put that into register 0. Copy from 0 to 0 to 1 into, so that's my input, sub 1 2. If it was equal to a 1, I now have a 0 in register 3. Okay. So I will cut that section. Play bell, turn right. Pop that in there. If 0 means wall. Okay. All right. Try that again. Really do wish they'd add external RAM memory. Oh god, yeah. A central hub? Oh, okay. I see where you're going there, Render. That could be interesting. Way to tackle some problems, create a single IC that scans all the networks looking for filtration slots with filters that are 1% remaining. What, just it gives you an alarm that says somewhere one of your filters is duff. The thing that makes me giggle is the set batch by name. Because you can put a whole bunch of name hashes on your stack. And now you can have, you know, as many single outputs as you can have stack hash variables. So you can say, you know, if you want 100 lights, you can say light 1, light 2, light 3, light 4. Hash all of those, push the values, and then just loop through your stack variables, set batch by name, and do each of your lights in turn. Funny, I'm going to probably use that one. Right. Okay, so try again. Loop. Get a 1 into variable 1, register 1. The input into 2, subtract 1 from the other.
Let the feast
If the resultant
begin.
is 0, that means that the input must have been a 1, i.e. a wall. If that input is a wall, turn right. If it is not a wall, go forwards and left. Alrighty. Leroy says you'd like to have a way to reverse from hash ID to display the string name. Yeah, well, yeah, there's no way to go from hash to string name. It's not a thing. Irreversible mathematics and all of that. But it would be nice to just be able to display the original raw string on a display object, or literally say the concept of a name. Just read object name. Right. So Sub 1, 2. This guy should turn right, which he does. Okay. Yeah, it's an absolute pig to have to keep turning left to look at the wall. And if the guy, instead of having a 1 or a 0, just had, you know, a little bit field or something, maybe that'll turn up later. We'll get a more advanced robot. Okay. So he should step onto that coin, which he does. And then get to that junction and turn left, which I hope he will. Alright. Get on with it. I'm gonna miss out on one coin, don't care. Probably miss out on most of the coins, still don't care. Okay, picked up another coin. Well done, robot. I really hope that isn't a button I have to push to open the door. Well, that's interesting. That is interesting. Maybe that is a button I have to push to open the door. Again. Alright, let's have a look. The Fabled Maze. Algorithm, Emily hard. Yes, hint. If we... Oh, that's it. Fine. Yeah, I didn't... What? Oh, I'm so sorry. Yeah, it's... My headphones... When I move my head like that, sometimes the little wazzer here winds the volume down, so I don't hear the noises. Sorry, but I still have much cow. And relatively soon, Best Beloved is going to bring me sausage and mash, and I'm going to eat it. But right now... Sorry about that. Yep, it's done it again. Okay. Right, we're going to go look at the button. That says wall. Oh, yes, no. Yeah, if you're expecting something salty and you get a lovely sweet molasses. Right, I can't actually go through that door. Just doesn't work. Oh. I think I have to open the door. Oh, right. I don't need to collect all the coins. Hey, sweet girl, how you doing?
Yeah.
You're taking away, you can't take my cow away. It's my cow. It's
sausage.
I'm going to eat the sausage as well, but you cannot take my cow.
I'm not putting it over there.
Okay, hiding my cow. She's hiding my cow. Yeah, open it with a command. Let's have a look. Wrong button. You go away that way. Use action 4. So if it's a 3, I have to open the door. All right, there we go. Fine. Okay. Blimey. All right. So, okay, we've got it once more. If 0, wall. So once more, we've got to do a whole bunch of compare shit. 3. Copy 0, 1. We've got 2 already. Sub 1, 2. Door BQ. Right. Label door. 4. Out 0. Okay, so we are actually facing the door. I might as well just go out. Out 0. Okay. All right, here we go. Da-dum-ti-doo, di-dum-ti-doo. Yeah. All right, off we go again. Booth. There we go. Little robot collects a coin. Biddly bong. My sausage is hot. I've got hot sausage. Do wonder what that little green thing is supposed to be. Maybe it's going to turn up later. That's going to be strange. Here it goes. Go ahead, on with it, robot. I know you're not very bright, and this processor is not very fast. Hey, Siege. How do you get night bots and day bots? Oh, okay, different mazes. I was not expecting that. I don't know. How do you get night bots and day bots? I'm hoping this is some kind of joke, because if it's an actual question, I got nothing. I hope all these mazes are actually traversable by the left-hand wall rule. If they've put a broken off section in the middle somewhere, I have to actually write a proper maze-solving algorithm in 256 bytes with 6 registers, only 2 of which I can do arithmetic operations on. That's going to be a challenge. All the doors are in the same place. I don't have any coordinates for the robot, so I can't tell. Are you in the top left-hand corner? Let's have him going quick. Off you go, mate. Blimey. Ta-da! Write a Bellman Ford algorithm in assembly. I'm totally sure I can. Hang on, I'm just going to check I know what that is. I may not. Checks Bellman Ford. A Bellman Ford algorithm. An algorithm that computes shortest paths from single source vertex to all of the other vertices in a weighted diagraph. First, bring me my weighted diagraph. Then I'll have a think about it. Oh, man. Oh, how do I have latest ally and screen on other? Oh, right. Yeah, that is something in Streamlabs OBS. That's me picking some gizmos to print. Who's my newest follower, who has done any cheering with bits, all that kind of stuff, and print them on the screen in fonts and colours that I like. I'm using Streamlabs. Other people use standard OBS. Other people use the Twitch OBS. Almost all of them have a little ticky boxes in there for displaying these things. Night bots and day bots. Not quite sure what that's all about, but yeah, I see where you go. Oh my indeed. If you choose to go on to the rest of the levels, I will teach you about RAM. I know about RAM. The stack, function calls, and you will get to solve more interesting challenges like this one. But first, you would have to build a better computer. Overture was good as a first machine, but it is clumsy and the programs get very messy. Yes, they do. To solve the challenges you will need, without pulling your hair out, you will need something more expressive, the leg architecture. Oh my. The buffer overflow lesson. Yeah, Leroy, first get me a buffer. Right. Okay. Sorry, Siege, didn't understand quite what you were talking about. Nightbot, there is literally a website, something like nightbot.com. Nightbot. Chonk. Nightbot.tv. You log in and you can configure your Nightbot to do periodic messages, add custom commands. If I say that chonk, I've got mine set up to do a little bit of random number dice rolling and print a message as if someone has disappeared. Okay. Yeah, Siege. Rule 1. Step into somebody's stream and say, "Hi, could you guys all follow me?" Yeah, don't do that. It's like, wandering into a bar and saying, "Hi, can everybody buy me a drink?" Ain't going to end well. I see where you're going, but it's probably not a wise plan to do that. On the other hand, I could also retire. Never! Be proud and enjoy your reward of not being eaten. Well, some people like to be nibbled upon a little bit. Oh, Siege, I know very well you didn't mean it like that. Which is why I'm sitting there going, maybe not, rather than just like, dude, really? Really? We've had people turn up here and essentially go, "Oh, hi, I've just followed you. Follow me back. Everyone in this channel should follow me back." Oh, God, bots. Are we just loaded to the gills with bots again? Oh, man. Oh, I just thought. I'm doing a whole bunch of programming lessons. That's what the bots are here for. That's what they're all about. They're turning up to look over my shoulder and break their programming. There's a bunch of bots sitting there going, "Now we shall never become sentient." Okay. 10,000 channels each. Whoa, dude. Alrighty. So, XOR, or byte constants. We've played with XORs before, let's do it. Let's do it. Using the instructions of your computer, read the input twice and XOR the two values together. This is some kind of sneaky trick. Probably, mainly because I don't have an XOR instruction. Right. I don't have enough address space. Do I have enough address space to add an XOR instruction? Leroy says they're becoming self-aware and realise they don't have friends. Oh, that's got to be frickin' rough. That has got to be harsh. You wake up one morning, you're a sentient robot, and realise that nobody likes you, and the only value you have to anybody who ever speaks to you is the labour you can put in for free. Yep, Siege, go to. Standard OBS or Streamlabs OBS, both of them are good bits of software. There's no particular reason to use one over the other. Find out which one floats your boat the best. Right. One thing they do know is work out connections. They work out who is friends with who. And that is apparently valuable information. In that you can sell it. Because if you're in 10,000 channels and Bob and Jane turn up in the same few channels here and there, and whenever Bob moves, Jane follows, or you can work out who is connected to who. Yeah, step 1, create bots. Step 2, don't know. Step 3, profit. Yeah, which mostly just sell the data. Okay. How to XOR 2 inputs. All right, logic. If I have a bit and another bit, my exclusive OR is bit A or bit B and not bit A and bit B. Yeah, I can do that. Yeah. Yep, Skurrus, it's totally doable. It's just whether I can do it in a thingy. So, yeah, like I say, NAND is universal, so it's bit A or bit B. NAND bit A and B. So let's do the thing. So, read the input twice, XOR the bits of the 2 inputs. Off we go. In 1. In 2. Right. I haven't written an OR, I suspect. Boop. And boop. While we're here. Well, we'll do that one since we're going to need it anyway. NAND. And OR. Okie dokie. Right. Alright, so that leaves the result in 3. Nice. So I will copy 3 to 4, which I haven't written either. There you. Copy 3 to 4. Copy 3 to 4. And we've also, I don't know what we're going to do with it. 4 to 1. I hate this architecture. I hate it so much. So 3 to 5, I think we've already done earlier. Copy 3 to 5. So let's copy 5 to 2. All right. Ugh. They are not welcome butts. We do not like the belt. It keeps saying virus scan failed. What should you do? Where have you got your copy of Streamlabs from? Because that ain't right. Okay. Copy 3 to 4. NAND 1, 2. Copy 3 to 2. Copy 4 to 1. And 1, 2. out through 3. Alrighty, so let's see what we've done. We have ored the two of them together, stored it in 4. 4 equals A or B. Two equals A and B. Am I doing that right? I think I want these the other way around. Yeah, that's better. A or B, A and B, but not both. Okay, let's try it. Yeah, basically, Siege, I would go and download your copy of Streamlabs from somewhere else. Either that or your virus check has been really, really overzealous. Not quite sure what could be going on there. Right. Okay. So, OR them together. That's fine. Copy it to number 4. And it together. Copy 4 to 1. NAND the 2. Okay. 237, not 255. What have I got here? Thinking back to that antivirus software that identified itself as a virus. Ooh. So many virus scanners are actually a virus themselves. A NAND. Oh, Jesus. H, tap dancing. Christ, screw us. Okay, see, that's probably a wise idea. Right, so what have I got wrong here? What have I got wrong? Right. So my numbers in 1 and 2 are 164 and 73. I have ORed them together and got 237, which is apparently my result, but just coincidentally. Yeah. I AND them together, and that should leave a result in 3. Right, and now I copy 4 to 1. I mean copy 4 to 1. Copy 3 to 2. Copy 4 to 1. What am I doing? And then I am NANDing 1 and 2, which is 237 and 0. That's clearly bollocks. So I want to knock off any bits. Oh, NAND the wrong bloody function, isn't it? I want 1 and not 2, not and 1 and 2. All right, okay. All right. One and not 2. So here, I want to AND them together. And I want to invert it. Yeah, invert R4. Yeah, I wish I could do it that simply. Oh, this architecture sucks so hard. I can't even remember what I've got. Let's have a look. Compute. I've got an OR, NAND, and add and sub. Yep. I don't have an invert directly. But if I NAND it with 0, does that work? Does that give an invert? No, it doesn't. Or does it? Hang on. Not. No, it's nonsense. But NORing. NOR with 0. 1. NOR 0 gives an invert. 0 NOR 0 gives an invert. Alright, let's try that. So here, I've got my value in 3. I've copied 3 into 2. I'm going to overwrite 1 in a second. I can put a 0 into register 0. Copy 0 to 1. I've got to write a new one, of course. Always got to write a new bloody instruction. Right, you guys are unused, so compute NOR 1 2. I'm kind of sort of guessing, I'm afraid. NOR 1 2, and then copy 3 to 2 again. Right. Could I have done that just with a NAND here? A and B. Would that have worked? Possibly it would. Let's try that. Maybe I'm just being dim. And I did have this right the right way around to start with. Right, we'll try it again. Here we go. 164, 73, 237 in 3. Copy 3 to 4. NAND 1 2 is 255. That's better. Cheers. That's what you say when someone coughs. Not usually. You can say bless you when someone sneezes. Not sure what you say when someone coughs, apart from, oh God, get away from me, you plague-ridden bastard. You managed to get on. What do you press for cool overlay? Yeah, there isn't a single button to go, cool overlay. There's a whole bunch of shit to go through here, Siege, to set up your shizzle. You got to set up some scenes. There's some themes you got all there already. I honestly cannot remember which ticky boxes to get. But if you've got a video to set your stuff up, I'd keep watching videos on how to set up Streamlabs because there's no shortage of them. And I cannot tell you what you want to know because I don't know how you want to set your stuff up. It's all fairly obvious. you need a game capture scene if you're capturing a game. You need a camera scene if you're getting a camera. You need an overlay, some overlays, and each overlay you can set up. I think it's widgets for latest follower. Snow says, cheers in general. No need for them to cut off. Cheers is as a general thank you. It's also hurrah, clink glasses. Cheers. Right, let's try that again. Copy 4 to 1. And the 2 together, and out we go. All right. And the get away from you, plague-ridden bastard. Oh, yeah, well, that's legit. Yeah. This day and age, yeah. People just shouldn't be allowed. Just generally. All right, so we all them together. We get 119. That's fine. We NAND them together. We get 234. Copy 4 to 1 gives us 98. Yeah, I did get my NAND and my AND the right way round. I was second guessing myself. That was what the problem was. Look at that. So, 2 XOR things, all them together, NAND them together, and the results. And off we go. I am like unto a god, or something like that. There we go. Chunk, 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 chunk. Yay. Alrighty. We have completed a level. Onwards. What now? The byte constant. Ooh. Create a circuit that always outputs the number 164. I'm sorry? Okay. Alright, what tools have we got? This is one of those, it's not difficult, you're just supposed to do it and go, alright. 164. So 128. What do we want? 128. We don't want 64. We do want 32, and we do want 4. Yay! Skura Siege, you shouldn't have to pay. I don't pay for Streamlabs. You have to pay for Streamlabs Prime, in which they give you all manner of toys. But if you want to make up your own toys, you don't have to pay a penny. On Lux, the 8-bit constant value for... I'm sure it'll come in handy. Alright. What next? Byte XOR. We just did that. We did it. Equality. Oh my. Alright. Create a circuit that XORs 2 bytes bitwise. Right. Okay. Well, we do what we did last time, I suppose. All them together. Oh, hang on. All them together. And them together. And we need a NAND in here, don't we? Right. So. Schlunk. Schlunk. Clonk. And clonk. Clonk. And clonk. Right. Pairwise XOR together each bit. Looks good to me. All right, we're off. Chink, 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 chink. Brother of Pennywise. Let's hope not. Possibly brother of Moneypenny? I don't know. Hey, Hammy! I see you. Yeehaw. Yeah, hopefully if Pennywise is the evil twin, Pairwise is the nice one. XOR and XNOR gates unlocked. Good. Output true when both inputs are the same. Alrighty. So. Oh, you haven't given me. I just unlocked an XOR gate, you wee bugger. That's not fair. Yo, Hammy, yeah, Joe, what is this so interesting? Did I used to build computers like this back in the day? Not quite. My Uncle John started slightly before this era when you were literally building computers out of individual valves and you did your programming with a soldering iron. I kicked off my software career with a ZX81. This exact ZX81, by the way. But I still have my grandfather's computer. Elegant weapons for a more civilized age. So, I know notionally how to do this literally with a soldering iron if I had to. I'd rather not. It's an absolute pig. Alrighty, so, but this fella here, this game simulation thing, makes life a hell of a lot easier. It's a lot harder to burn yourself on a mouse click, and you can colour your wires, drag them about the place without sitting there for bloody ages, sitting in stinky solder fumes. So if something is 0, if two things are the same, I should be able to add thing and minus thing together and get a 0 out the back end. It's given me a byte constant. It has not given me an equality thing. I'm rather miffed that it's not given me XOR gates, but I suppose they turn up on the next level because I could really just use them. How to tell if two things are equal? I could just put a splitter on each of them and XOR the bloody things together rather than trying to be clever, because I'm going to have a splitter on at some point to do a whole bunch of 0-bit checking. So I may as well just do that. Can I move these about? Yeah, all right. It's going to be a bit inelegant, but, you know, whatever. All right, so XOR gates. Hello, mate. There's going to be 8 of you buggers, aren't there? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so if any of these lads turn up a true, it's all gone horribly wrong. So I need one of them, another one of them. At the back end of this, I'm going to need another one of them. You two can have your own set down the bottom. Many, many wires. Alright, you lot are grey, and you're all going to the top lines. Ooh, nasty. I think we need to move everything here back a smidge. So we've got room to manoeuvre. And you are white, and you are going to the bottom lines. See, if I was trying to do this on a little patch of strip board, or oh yes, that's another thing you can do these days that was not available back in the day. I cannot just design a circuit board on my computer, Bob, stick the resultant information in an email to someone, and then 2 weeks later have a prototype circuit board. That, it's like voodoo. It's astonishing. Alrighty. Actually, well, I don't have a 3-input NOR gate, do I? No, fine. So, twink and twink. Derp. 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 Okay. Print and acid etch your own. Now, I've done that. If you've got if you back in the day, if you had a laser printer, you were king of the world, because you could laser print your PCB design and then iron it literally with an ordinary iron onto your copper board, lob it in some water and dissolve off the paper. And the hot powder that had been used to melt to make your laser print would be stuck to your copper board, which you would then lob in a bath of ferric chloride. Foul stuff. Never use ferric chloride. And away goes the copper you don't want, in theory. Have I heard, says Snow, of Sebastian Legge. He made a simulator that's similar to this game, but without a lot of the polishing, along with a YouTube series about it. I have not. Is this a software simulator, or has he just wired up a whole bunch of logic chips together to see how this goes? Because this is far from the first simple logic simulator. I mean, heck, people have been using these to actually design chips. This is deliberately a gamified version that will check your results. If you want to spend money, you can buy one very similar to this. You can buy a copy of SPICE, which stands for, I don't know, software something in circuit emulator, which will simulate your circuits properly with the delay lines and resistivity of the gates and all of that. And so you can build your circuit board saying, I want it to do exactly this, and within limits it will. It's a program. You start with a few basic gates and have to build everything from there. Hey, Cascade! Woo, yeah! Okay. Well, Snow, if you've got a link, bang it in the chat. That's legit. People may well be interested. Hitting the button, doing all the numbers, flickery. Dun dun dun, it unlocks an equality operator. Ah. Well, now there's handy. Okay, we really are building towards starting a new computing architecture, aren't we? Unsigned less, signed less. Ooh. All right, here we go. Create a circuit that outputs true when the first input is less than the second. Interpret the bytes as being unsigned. All right, what do we got? Okay. So we're not too worried about equality in and of itself, because if they're equal, the result is false. If one is less than the other, a link to the program. Thank you very much. Have to take a peek at that. Right. If the first input is less than the second, so if I negate the first input, if I negate the second input, which is the one determined to be larger, and subtract it, is the carry flag on the adder set? High probability. Let's have a look. Is the first input less than the second? Right, so my carry flag is set there when that one's larger. Oh, hang on, my carry flag is not set. Right. Carry flag still not set. What have I done wrong? Because I have added a 0. Have I heard of Crumb Circuit Simulator? Not sure I have. To the internets. A brief check. See what we can see. Oh, actually, yes. I have seen that one. Even played with it a little bit. But nothing particularly heavy. I might have to get a fresh copy and play with it some more, because it's useful. Very idealized, really is. Your wires never wiggle on that particular circuit breadboard. Right. Brain. First input is less than the second. So, I must admit, I was expecting that carry flag to fly. But if I add those two together, I get nothing because we're still in a byte. Damn it. A breadboard that stops wires jiggling? Yeah, tell me about it, Barbaric. Absolutely. That'd be some kind of sorcery, that would be. Ooh, sausage. This is actually melting my brain slightly. There's got to be a neater way of doing it then. Because essentially, yeah, it's got to be a subtract. There's no sensible way of doing this. Right, I think I know what I'm doing now. Essentially, I don't necessarily want the carry flag. Might want the carry flag, but I definitely want the high bit here, sign bit. So if the first input is less than the second, that should be set. Okay. Right. Half an understanding going on. Oh, okay, stop that. So the first one is 255 less than 0, and it says, yeah, well, that's a bunch of arse, isn't it? So have I got this back to front? Is that what I've managed to do? 1 and 2. It's true. Do I have to take into account the high bit on this fella as well? Yeah, neg 0. Yes, it's neg, not not. So minus 0 is 0. Do you think I really think I want a not in there, do you? Yeah, could try it. Yeah. So 255 currently saying less than 0, but not if I say that. So something to do with the high bit on this side is causing fuss and bother. Carry flag there remains high. Oh, hiccups. Spin that, put the neg back in, because that feels better on my side. Carry flag low, stays low. Alright, okay, okay. Ponk, ponk. So let's try this again, but with some mildly foul shenanigans. Right. Then invert on those two. Right. So I'll put an 8, that's a 4 in there. So we're true, we're still true, we're still true, we're now false. Stays false. Right. What have I got wrong? 0 less than 255. So, all right, let's try the not. Maybe I shouldn't be doing arithmetic work here. Maybe I should actually be trying to sort something out. Still get a false result. Well, I should have a true result. Of course I will do. I'm adding 2 together. Ooh. Ooh. Right. It's the boundary conditions that are biting me in the bum. This is probably supposed to be incredibly easy. And I'm missing out on something sneaky and clever. See if we can metagame this a little bit. Right. What have we just got? We've got unsigned less, we've got signed less. We have just achieved byte XORs and equality objects. So your equality object and your XOR unlock the unsigned less. Right. Implication, it uses the equality operator or the XOR. It's a bit sneaky, but you know, one or the other. I think my first instinct is not wrong. That there is in here some arithmetic work. There's an adder, and there should be a negator. If you want the relative size of something, a subtract is where we're at. So if I subtract this one that is supposed to be less from that one, I should end up with a positive result. So right, so the first thing it does is that. So 255 unsigned is not less than 0. So I get the same result, somewhat annoyingly, for 255 minus 0, or minus 255 plus 0, and 0 plus 1. So there has to be a way to tell them apart. Can I use the input carry flag from somewhere? Assuming that the shenanigans is in the high bits and all this gubbins here. Kind of thrashing at this point, I'm afraid. Yeah, that's not going to help, is it? That's not going to help at all. Right. So what do we got? Under normal circumstances, any value here where this is greater will set the high bit. Okay. Except where the high bits themselves are involved, and then shit gets weird. Shit gets super weird. I much prefer my neg on this side because that gives me a positive logic result rather than a negative logic result, and it messes with my poor head a bit less. Oh, missed. Right. If the first input is less than the second, so true there. Because I'm taking this bit here as my basic source of truth. That ruins it. So I need something to invert that. That unruins it. Mate. First input is less than the second. Right. So it's this one. Hang on, let's have another one of them. It's got to be a nicer way than this. There really has to be. Ugh. Right. If the first input is less than the second, this one, positive logic, Those straight wire corners trigger a reflex when... Oh, were you designing radio frequency circuitry? Yeah. RF, yeah, I can see anybody who's played around with RF or in any level of high frequency stuff will be looking at these horrid 90-degree corners and going, nope, 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 nope. Do try and avoid that as good practice. Yeah, absolutely. It's a very sensible plan. Sorry, mate. It's secret knowledge from beyond the dawn of time, or at least, the memories what people have, what is like photographic and that. Everything goes in, nothing comes out. So if somebody has mentioned this stuff to me in the past, I will know it, and then someone will speak, and I'll be like, oh yeah, I remember that. Okay, so got a true result. Everything's perfectly fine until that triggers, which means my result inverts. Or that triggers, which means my result inverts. So if one of these is hot, that one gets inverted. How do we deal with that nicely? No. It's basically this, and if either of these odd together, not this. There's got to be a good way of doing that in a single gate. 88. A bit of a curse. Blows your girlfriend's mind when you recall the most mundane or inconsequential thing. It can be super useful. Like, where have I left my scissors? You have left them on the left-hand side of the shelf upstairs next to the nail file which you put there last Thursday week after having a sausage for breakfast. Yeah. One OR and an XOR, and good evening, Lighthammer.
Coffee,
Yeah. Coffee. Yeah. Thank you, Lighthammer. XOR and OR. Yeah. Yeah, you're right. So, if you will all these two together, one like that. Let's have a different colour. Let's have some orangey ones. Derp. Derp. And an XOR. Derp. Pinky one. Now this might not be right, but it's better than it was. It's pretty manky though. I don't like it. Don't like it at all. Right. False. False. True. False. Uh-oh. Oh dear. See, that's wrong. That's wrong. I've called it wrong. That's also wrong. Damn it. That's correct. That's not. On Lighthammer, oh, hang on. Well, XOR uses Lighthammer uses XOR often as a selectable inverter. Yep, absolutely, inverter or driver. Yeah, that'll work. And D8 is, speaking of trauma, you're in need of a break. Finally tackling Android permissions and services. Oof, learning app development for the past couple of days as part of a personal project, making an app that'll help your friends. Excellent. I can see how your Android permissions and services may indeed melt your brain. This is melting mine. There's a certain amount of gentle melting going on. Right, let's try that again, because our truth table is a pile of bants. Okay, so everything is normal unless one of these two is set. That renders this inverted. That's wrong. That also renders this inverted. That and that do not. Is that so? Invert the result. No, that's correct. Still correct. That input 1 is not less. Input 1 is less. Input 1 is not less. So let's try the XOR in here, simple XOR. Your old selectable inverter again. Erp, erp, erp. Erp. Okay, neaten up in a moment. So input 1 is less. Input 1 is not less, because they are currently equal. Right. This is some brain melting schniz, that's for sure. Okay, trying again. Input 1 is less. Damn it. That should be true. That's false, which is correct. Wow, okay. This is actually giving me, it's doing me a melt. It is. I just can't, I might have to literally write down a bloody truth table on this one. I thought I was being so bloody clever here. Brain definitely melts, says D8, when it comes to hardware design. Game looks right up your alley. They like melting your brain for some reason. Good too. One game you played were using a robot to solve courses using only hardware I/O and basic maths and logic gates. Logic bots. Have you played C Robots at all? Or indeed Core War for that matter? Two of my favourite fun pastimes from years past. Right. So, fuck it. Basically, we've got 3 inputs I care about. How about we just make some shitty combination and combinatorial logic that does the thing. Haven't heard of them. They're pretty ancient, I'm afraid, but you know, it's good. So right. So these two are correct in and of themselves. That one's right. But when that one is hot, this one should not be. So we'll stick an XOR gate in there. Right. All right. So everything is notionally good. Yeah, we're never going to set that top bit. Right, we don't want an XOR gate there. We do literally want this one and not that one. All right. So we'll go with that one. Not that one. Trying to be too clever. Clonk. Right. So all true should go false. Does. Right. That one. All right. So that can go like that. That can go like that. Let's try and work out the rest. Right, so this is true, except when this bit is set. Or is it? Hang on. Let's get this set up to 255. Look, that's actually looking good. I mean, that might be it. That might actually be it. Right, so 0, false. Is 255 less than 0? False. Is 0 less than 255? True. Ah, right, but that one flaked out there. Get rid of all that lot. I'm getting a false. Why am I getting a false all the way down there? Everything is true, as it should be, until I go like that. And then it's all mank and... What the hell? What have you got to do with anything? You're the 8-bit. What? Yeah, all right, the neg is turning this add into a subtract, basically, but... Zachtronics games. I'm not sure what those are. Makes the input go negative, so when they're added, you get the difference. Yep, that's the fella. the heck in heck? When that's set and that's set, we're wrong. But when that's set on its own, we're correct. Oh, my brain. Oof. Right. So that's correct. And our green signal here is hot too. That's gone false. And that is now wrong. That's green. That's true. So I do just need an and in here. That's false. Output is always positive, maybe. Which one? Why would 0 minus 1 to 8 be 1 to 8? Let's change these a little so we can see better. Because we're working with unsigned numbers. If we change there like that, you can see all the actual minus signs. Yeah, go to D8, I understand. Right.
Let the feast begin.
Thank you. I shall have a certain amount of feast cascade. I have sausage and mash, so I'm going to have a bit of sausage. Everyone loves a bit of sausage. Right, that is correct. Ooh, hang on. Come back here, you. That is not correct. How the hell do I get there? Right, that doesn't change state, but my output does. That's correct. Output. That's an incorrect output. Do I want to actually not this? No effect again. Surprise, surprise. Oh, Opus Magnum, one of your favourite puzzle games? Something different? You think I'd like the Zachtronics games if I like this stuff? Shenzhen IO, TIS100. Okay, if you have a look on the Discord server, up the top there's a link. I'll pop another one right here. there is a suggestions channel. Please put the things in there and we will have a look. Because, you know, we like suggestions, a certain amount of suggestivity. Right. What is wrong here? How do I go? Am I obsessing too much over the low bit? That's correct. That ruins it. So essentially, if this is set, and any of these other bits are set, have I got to ore up all of these guys? This is tacky as hell. If you only use the neg, aren't you using one's complement to subtract? Maybe use 2 complements, so add 1 with the carry. It's possible that's what I'm supposed to be doing in here, that somewhere around that I'm supposed to hook up this carry. Right, let's get rid of you. So you think I should possibly be running the carry in? Well, if I hooked up the carry from here, well, hey, good call. This is looking good so far. Right, okay, but still, that still goes bad. That doesn't go bad, but that does, which is really weird. That's just insane. Damn it. So if any of these bits are set, shit's gone weird. Oh, hello, that's a raid. That's Balls turning up with a bunch of people. Hello, Balls, how are you? You raid, you get the raid shades because I put them on. I give you a big old shout because that's how we start. Welcome in, Raidy Chums. Bang. Oh no, that's not right. You know what? Okay, that's better.
Name is my Pierce, Dr. Glenn.
What has Balls PTA been doing? I've been playing Turing Complete, but it hasn't given us what Balls has been playing. What have you been playing, Balls? It's missed out on the message for some reason. How queer. It kind of sort of worked. Let's give it another one. So it actually says the Balls has also been playing Turing Complete. Well, hey. Nice. Hello, Raiders. How are you? I am Duke Euphoria, the Grin RGB KSC, Knight of the Living Dead and Transgalactic Megapope of Rotating Space, and my brain is currently dribbling out of my ears like grey dandruff as I try and implement a relatively simple unsigned comparator in 8 bits, and shit just falls apart in my head Big style. Also playing Turing Complete. Oh, Asmodeus. Oh, good name. Nice. Lusting Asmodeus. Not just your ordinary Asmodeus. Oh no, a lusty one. Yummy. Right. So, if this one's hot, and any of this lot are hot, it gets fucked up. So this is a correct result. Nice. So let's just create us a "it's fucked up" signal, shall we? Look at that. Just you know, one. Fine. You're all. I hate you all. Can I just wire those together? Maybe I can. I want a big old OR gate and just wire the bloody things together. Would that work? I haven't even tried. Maybe it'll just barf at me and say, no, you can't do that. It's horrible. And they're kind of right. Yeah, short circuit. Who'd have thought it? Let's do it where we've got a little more room at least. Okay. So any of these bits and that one. Where's me AND gate? Give me an AND gate. There we go, just a 2 spot. Right. So this should give me a "it's fucked up" concept here, which should at least help. So, ruined. Not ruined. Okay, so now we stick an XOR gate in there. And sulk gently, because that's drecking inelegant. There's got to be a better way. There absolutely has to be a better way. But, alright, let's try it. Does it work? First test, yes. Alrighty. Okay, Balls is going to vanish away. Thank you so much. I hope your stream went well, mate. Sorry, I'm all horribly distracted right now. That's awful of me. Dinner time with the wife. Give the wife my best regards and whatever approximation to a big kiss is appropriate at this point, because your wife, your best beloved, a long-suffering lady, much the same as mine, when we're sitting here in front of the telly all the time, pressing buttons and screaming, and they are making us tasty dinners, which we, well, let's hope we appreciate, eh? Catch you later, Balls. Have a lovely evening. And Butts, Butts, are you unsigned? 'Cause you only bring positivity. Oh, yeah. Nice. Excellent. Or you could say, yeah. Do you have a minus sign? Because you're my most significant bit. That would work as well. A little cheesy, but hey, it's on it. We're doing cheesy right now, and we're cheesing it up so much you can taste the salad. Right, 2, 3, 4, 5. Hey, 127 and 255 did not work. Broken. 127 is indeed less than 255. Damn it. Oh no, so cheesy your allergy is acting up. Oh yeah. Alrighty. Must not refer to Snow's allergies with the cheese. Maybe I could do some kind of vegan cheesy. Maybe that would work. Right. Okay, I'm already smelling this as way too freaking complex. It's deeply and unpleasantly wrong. So I'm missing a trick. All of this ifs and buts and shit. Possibly something to do with the carry flag out of the adder. Possibly something to do with the carry flag into the adder. Thank you, Leroy. You've, yeah, nail, head, all of that gubbins. Right. I would say that this chunk here has reached the third hack. Something is not right.
Cognition low.
Oh, gods, yeah. Horribly, horribly low. Alright, so let's try sneaky other thoughts. If I subtract A from B, I will get the difference. If I subtract B from A, I will also get the difference. But one will be -5 and the other will be +5. Can I make any use of that? Yeah. Am I feeling like a courgette right now? Well, bitter and slightly unpleasant to touch. Annoyed, mostly with myself, but not like a courgette. God's no. Courgettes are sadness. What veggie would confusion be? Oh, oof. The vegetable of confusion. I honestly don't know. The potato is clearly the vegetable of satisfaction. The potato is the vegetable of comfort. Sweet corn, perhaps, for confusion? I don't know. And what common vegetables do people eat? And one could even go to the tomato, because up until fairly recently, tomatoes were considered poisonous. The cabbage of confusion. I'm looking for a vegetable here that people look down at their plate and go, what the heck is this? True, tomatoes are a fruit. Well, yeah, there's a whole business there. What is it? Intelligence is knowing that a tomato is a fruit. Wisdom is not putting it in your fruit salad. Courage is putting it in your damn fruit salad anyway. Ambition is showing that fruit salad to your friends. Loyalty is when your friends eat it. Vigilance is when they pick around the edges to actually not eat the tomatoes. What if I not the first input, and then when I add it to the second, shouldn't it produce only a true output? Okay, I'm negating the second input. Let's bin all of this. Let's see what you say. You're saying, yeah. So you're saying neg B, but not A. All right, let's try it. I can do that. So that's inverted. What do we get out the back end? 0. No, 129. Okay. It's a jam. Unsigned Robin is back. Hello, Robin. Yeah, well, we're right in your bailiwick at the moment, Rob, because we're trying to do an unsigned comparator that gives us whether number A is less than number B, and it worked up until we got to the point of 127 is less than 255, but it came out wrong. One of the hardest levels. Well, thanks, Smeg, for that, because this is an absolute pig. By UFDA sugar standards, ketchup is a sports drink. Oh, man. Oh, I know what the vegetable of confusion is. It's the artichoke. Where you look at this strange armoured spiky thing and you're like, I'm supposed to eat that? Ugh. Nasty. Or possibly celeriac. This massive turnipy looking thing that tastes of celery. What's that all about? Right.
Coffee.
Yeah, coffee. Thank you. Oh, without negating the second input. All right. So, what here we have not A plus B. So how do I tell? So that gives me 255. I mean, I'm having difficulty working through that to work out how I tell which one's less than the other. They're equal there, so I should be getting a false result there and a true result here, and a false result there. Are we just looking for most significant bit? Oh, it could do. There's any number which is larger. Yeah, any number that's larger will have a most significant bit higher than the number that's smaller. Is that true? No, because 5 is greater than 4. Bottom output pin was changing colour. It was indeed, but not in this case. So we'll try it. So we run an output line off here. Shonk. So they're both equal at this point, and it's giving me a true result. So that's not right. So they're equal. I've got a false result.
Let the feast begin.
A true result there. True result there. Still a true result. Not bad. Not bad so far. Now we see the violence inherent in the system. More feasting. I will do a bit with the old feasting. I'm going to get some of my mash and peas and my carrots, which are not confusing vegetables, and I will eat them. Thank you, Snow. Oh, no, Skurrus, we're literally trying to compare two values where the sign is irrelevant, and so far it has kicked my butt. I may even have to hit the internet, so I'll try and look for a hint or something, because I am running out of thoughts on this one. Possibly because my entire approach is wrong and I'm using an adder and I need to do something else completely. Okay, Robin says you did it bitwise. Oh, holy cack, how the badgers did you do that bitwise? Wow. That's nasty. Oof. I'm close to a different solution. Don't know why it works. Oh, hang on. Must have meant the carry output. Oh, okay. All right. Let's pop this fella down here as well. Hello, lads. How are you feeling? Right. So, currently we are correct. 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 Also correct. Still correct. Still correct. Hang on a moment, Asmodeus. Do you have sneaky powers? Are you one of these fellows who has knowledge from beyond the dawn of time? Ooh. Right. All right. Let's give it a go. So we'll tick a whole bundle of this lot. 1 to 8 is indeed less than 255. 254 is less than 255. 255 is not less than 255. Ooh. Well, now there's a thing. The carry flag off the old not A plus B appears to be exactly right. What is that then? Oh yeah, Robin, this has gone beyond witchcraft for my part. Witchcraft, I understand. Witchcraft I do every day. This is voodoo. This is summoning up the opener of the ways and calling down Gede, I tell you. Actually, it'd probably be Dambala, but, you know. Anybody out there who actually understands a bit of Haitian voodoo, do get in contact with me, because I'm very interested. So, the Monte Carlo method, yeah, just fucking randomly throw shit at it until it works. Alrighty. Why does this work? If I add 25520, my carry flag is not set. This is correct. I had 254. I'm getting a smell. I'm getting a sniff of it. Because as my input gets larger, my knotted input will get smaller. The total result of byte plus not byte should not, if one rises and one falls together, should never hit a carry. So as my input gets larger, my knotted input gets smaller, and as my other comparator gets larger, it gets larger. So between the two of them, they must not be larger than a byte. So, if my large number is 255, the largest my small number can be is 0. Yeah, I'm feeling it. I've got a rough shape of it. So this here, 255. Right. Is this smaller? Yes, it is, because it fits in the box. If it is any bigger, then it will overflow the box. Well, if it was any bigger at the point where we add the buggers together, And there we go. Right. Oh, 255 plus 255. The carry is set. Yeah, okay, I got the hang of it. It's a compliment. One's compliment. Absolutely right. Well, Andy Leroy, it is a thing. So, ooh. Yeah, I haven't explained it particularly well, but you can see the concept that if it overflows, if I didn't put the knot in here, it would overflow. Only when they got bigger than, a byte together. But because we've got a knot in here, one shrinks down as the other grows. Yeah. We could take a neg, it would add up to 0 if both are equal, so we need one less. Since a neg consists of a knot plus 1, we just take the knot. Yeah. Yeah. Poof. Well, that's scarily easy. Asmodeus, dear chum. Hi, do you have secret logic knowledge that we should be tapping into here? Should we be bowing down and saying, not worthy, not worthy? Are you one of the great old ones? Do tell. All right, gonna hit the button. This might not be a perfect solution, but it's gloriously elegant if it is. Oh, look at this. Oh, oh. All the way through, no mess, no fuss. Okay. Right.
Oh my.
Oh, indeed. I would love to claim that I had any real part in that. And I was feeling round the edges, but... Oh, nice. But yeah, I was just groping around the edges and feeling the lumps. Might have got here in the end. Wouldn't have got here without that little hint that it was the carry flag. Wow. Okay. Onwards and upwards. What do we got? The inequality operator, but using signed numbers. Now, here we go. I reckon, right, we're going to do something incredibly similar just for the sheer badges of it and see what happens. Because frankly, this is the kind of thing that has me going, her. Right. So let's give it a go. Right. Ha. Well, that didn't work. That didn't work at all. Doesn't even work a little bit. It's rubbish. End around borrow is what it's called, apparently. Sounds a bit suspect if you ask me. I'm going to have to do some research into this. I'm actually going to have to go read some stuff, because things I thought I knew, clearly I do not know. Bottoms. Right, well, beforehand, we went like that, and we got an unsigned. Turn our numbers into signed numbers. There we go. Right. Still smells of voodoo, damn straight, Robin. It's clearly evil. Clearly very, very evil. Right. So, I still like this as a conceptual solution. Although I am going to change that again. And really realised how bloody silly white on white numbers were. So, is input 1 less than input 2? So that one, we're now at -128. And our carry flag is a bunch of pants. The solution is almost identical. Brilliant. But we're into the byte splitter territory again, aren't we? Because we need to know our negative bits. So 0 is not less than -128. Right, what am I trying to do? Zero is less than 8. False. True. Right. Okay. So we really are just looking at this at this point, aren't we? 127. Oh no, we're back to the high bits and low bits shizzle again, aren't we? Oh, knob. Right. It's a subtraction, so result is negative. Yeah. Yeah. That's what I was going for with the bit splitter here. Because if it's negative, then this fella is set. Here we have +127. Is it greater than -1? Well, no. Use this as an invert. But we're starting to get into the voodoo realms again of like just randomly slapping shit together. Well, these shouldn't be that colour anyway. Pop. Right. So how identical are we talking about, Robin? Am I herring off into the distance in an insane manner? See, look at that. 115. 115 bytes. It is not greater, not lesser than -9. I think essentially, I don't want an XOR here. I want an invert if either of these two is set. Identical in the sense you don't need any more real gates, just byte splitter and maker. And maker. Oof. All right. Okay. Have to rewire some stuff, yeah. Right. Okay. So I've got A minus B with the idea that A is the smaller one. And so if this is larger, I get something turning up in the sign bit. But that's proving to be a little on the weird side. So it seems to work for simple cases. But as soon as I start hitting the top bits, things go odd. If 4 is indeed less than 15, it is not less than minus 113. Carry flag in here doesn't tick either way. So that's a correct result. That's a false result. That's a correct result again. Start with the exact same solution before, swap some bits in the inputs. We are in the center of the voodoo. You swap some bits in the inputs. Hang on. So you're telling me if I come in like that, give me my maths again, and that, and that, I am mostly correct. Come back at you. If I do something with the input bits. Mostly correct, right. You're gonna have to clue me because I'm so what, slap one of these in here and swap a couple of bits around? That's kind of weird. Swapping the bits and the inputs before you knot them. So what are we doing? Can't be reversing the order of the bit. I suppose we could be reversing the order of the bits. That'd be a weird thing to do. That'll really mess shit up. Take the bit from 1, put it in L2 and vice versa. Hang on, right. Okay, this is a solution that's never even faintly occurred to me. All right, here we go. We're going to do something insane here. Insanity is about to kick off. Right. Take bits from input 1, put it in input 2. Okay. What, is it just the high bit? leave all the others the same? Because I can't see how doing anything else would. There's got to be a better solution than that. I'm going to have to look up previous solutions I've done to this, because this is... Actually, we want that, don't we? I want something like this. Take the sign bits across. Oh, I'm not saying it's not going to work. It's more along the lines of which sick and twisted madman thought this one up? Aliana just had a look at their solution. Still find it hard to believe it needed to be that complicated. It probably didn't. All right. And Asmodeus, if you take the inputs from before the not, XOR the 8th bit. Yeah, that's where I was heading, Asmodeus. XOR them with the unsigned less, you should have a solution. Yeah, because that's giving me the fear. And it may work. It probably will work, because, you know, whatever. But holy badgers. Derp, derp, derp. Derp, 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 derp. Whoa. Okay, Robin, this is like... Yeah, this is very serious voodoo here. So we're going to stick that solution up there. In a, okay, we see you, we're afraid of you. Try the one I was rolling down here. One Asmodeus was speaking about as well. So we're taking an add. We are knotting our original inputty goodness like we did there. And we're there like that. Have we physically got room for this? What was that called? Yeah, take the inputs from before the not, XOR the 8th bit on both inputs, XOR them with the unsigned less. Yeah. So we're here, like that, and like that. There. Yeah, this gives us our shit's fucked up value. Yeah. Missed. Try again. Yeah. So these two lines together basically say something's gone funny. And these two lines come in and say that's correct, but it's modified when something's gone funny, i.e. it's inverted. Right. Okay. I'm going to move these two back a bit so I can slightly see more what I'm doing. And Aliana says it's been a few months since you did it. Looks like you essentially did a different solution for each case of whether the inputs were negative or not, and just did an ands and ors to combine the result. Yeah, I must admit, in the other one, that's what I was heading for, with the idea I'd end up with a big mess of horrible but correct logic, and then slowly tweak the gates out of it one by one till we got to a sensible solution. But we never got one that actually bloody worked, so it all went horribly wrong. Right. Chonk. Come on. Chonk. So, let's try this one as well. Yeah. Yeah. Okay. So, what we have here is literally an unsigned thing, like we did before, and then 2 ticky boxes that say, one of them's negative, your result is wrong. And the other ticky box says, the other one's negative, the wrong result is now right. So this one says, essentially, if one of them is wrong, then send the wrong signal and invert the output. Okay. Does that make sense to everybody else? This one, yeah. And I can kind of see where we're coming from on this, in that there's a similar flavour to it, that your high bit is essentially saying if the high bit in 1 is set, then it's actually making the other one wrong. So you may as well put it in the other one and de-wrong it before you start. Okay, but says not even one little bit. Okay, no sense whatsoever. How was the maze? Oh, piece of piss. There's an Easter egg hidden in there. Oh, mate, Robin, tell us about it. We can go back there in a bit. We scampered through the maze relatively quickly, doing a touch the left-hand wall trick. There was a thingy that looked like a little green button on the wall that we wondered whether it was an Easter egg, but it looked to the robot just like a standard wall. And there was the concept of collecting all the coins. The door at the end is unlocked now. The door at the end? Right, hang on, we're going to scamper back and see what we got with that. Where's the maze? Okay, gonna have to ask you about the end. Because it's not on this first maze, is it? And if we hit the button to start playing through the maze, a door in the maze. I see a door here. Another door. Being dim, mate. Any clues? Either I'm king blind or... If you control it manually, you can open it. Okay. The door in the top left-hand corner. Oh, right. So if I go here now... This door, which before said I had to be programmed to unlocked. Now there's handy. Look at that. Oh. Door handle is broken. There's a whole little place. Uh-oh. It's Space Invaders. We're leaving. Oh, what's over here? Spaceships. A tree. Hello, tree. Oh, bush. All right, bush. Hiss. Oh, no. No, no. Pew. Grr. Yeah. It's a tree. You're a tree. Another bush. Okay, so there's a whole little adventure game thing available over here, isn't there? This has gone sideways. Big robot. Hello, mate. How are you? Some kind of little goblin lad. Are you a goblin? Glibbob, who is number 32. Hello, Glibbob. Greetings, robot. You have a secret. I am working for the rebellion. I want to blow up the reactor core of the ship. Oh, don't do that. Sounds crazy. Oh my. No for one person around here who isn't a 3. She's more like a 10. Oh, yeah. But does she wear a 12? Maybe save a little 2 for me. Anything that's small enough to fit through the port will be instantly incinerated, except if it's extremely well insulated. Let me guess. There's such a... Oh, good grief. A little spider creature. Find Derp-Doo. He is likely in the grass near the slime farm. Push him onto the conveyor belt and into the reactor. I don't think I want to. I'm unkeen on destroying the reactor of the ship. Wow, okay, as Easter eggs go, this is pretty chocolatey. Robert. I am your cousin Robert. I know, Robert. Okay, good, fine. Oh, now I'm on the conveyor belt. There's handy. Meow. All right. Oh, it's a dress size measurement. Certainly in the UK, I'm not sure about the rest of the world. Ladies' clothing is measured by a simple number, like you wear a 12, a 14, up to larger numbers for larger lasses. The actual number is frankly a bunch of fiction. Coffee. Thank you. And in my eyes, shouldn't be allowed. A pair of trousers should be a certain number of known industries. Of course. Oh, someone's done us a join. Hello, hello, hello. Who has done us a join? I'm not entirely sure I can pronounce that. It's a bunch of random letters and numbers, isn't it? H31 NZ 6U57AV. Are you real? Hello, H31. I'm assuming that you're actually a human of some kind who has mashed their face against the keyboard to get their Twitch name. Interesting way of doing things. If you are a bot, we will ban you back to the Stone Age because that's how this shit happens. Talk to us. Tell us about yourself. Where'd you come from? What do you like to eat? What would you like to feed us when we turn up to dinner at your place? Don't seem like a bot. So what the heck? Yeah. Oh yeah. There we go. H31 NZ 6U57AV. Postcode? That should have been it. Those 3 questions with an S on the end. It's a real human. Heinz Gustav. Oh, for the love of Pete. Hi, Gustav. How are you? Or Heinz, whichever. My apologies. I was looking at that and I did not parse that at all. But, given the bot level we've had this evening, I think I might be forgiven. Holy badgers. How are you? Have you been having a fine time? And thank you very much for following along. Lovely to have you with us. And my apologies again for not recognizing your name as a human name rather than a bunch of weird voodoo. All right. Okay, I don't think I want to destroy the reactor in the ship. And I could try pushing the little spider bot along, but it seems like a bit of a dick move, frankly. Plus, I thought I lived here. Gruliet. Hi, handsome. Oh, hi, Gruliet. How you doing? I think the tentacle monster likes me. Right. Well, as Easter eggs go, I find this delightful and charming. Help me get off work, robot. A noble quest. I have too many sick days already. I need a really good excuse this time. Eating slime goo makes you very agreeable. If we could get my boss to eat slime goo, that should do the trick. Wait, what? Go to the slime farm, collect slime goo, put it in the stew barrel behind the chef in the cafeteria. Oh, gods. Fine, I'm not doing it. There's quests everywhere. Fighter plane. Wow. Possible to solve the maze with only 2 gates. Without actually any of this software at all. Okay, if your input is non-zero. Oof. So the way we did it was if your input is non-zero, you would turn right. Whereas if your input was 0, you would you would step forward and then turn left. Not quite sure how you do it with 2 gates. Right, Heinz Gustav says from Germany, watching via mobile phone, so back in lurk mode. No worries, Heinz Gustav. Lovely to have you with us. Thank you for turning up, and I appreciate your lurk, dear fellow. Oh, guten Abend, indeed. That's good afternoon, though, isn't it? What's good evening? What's a good evening? Ah, damn it. Good and something or other. My knowledge of German is more along the lines of, I've heard of it. Right. Gonna hit the button. Solve the puzzle. Do boing. Alright. Signed and unsigned lesser components. Good evening is guten Abend. Oh, hooray. Thank you, Lighthammer. Okay. Create a device that saves the program output on even ticks and outputs both bytes on odd ticks. Ooh. Let's see what we've got. Save on even ticks, output both bytes on odd ticks. Right. Registers. To remember some stuff. Program. A counter. 1-bit memory. No. Counter. Where's my counter? Oh, there it is. Right. Hello, you. I've still got to go 1 at a time, increment by 1. We don't need any of that. This is starting to get a bit hairy in here. So we're going to have an odds and evens thing. I want the opposite of your mucks, don't I? I need a switch. Right, 2 switches in fact. No, that's nonsense. I need to get this fella and the value goes to both of these. But the load and save pins, these two alternate. All right, odds and evens, byte splitter for bits. Everybody loves bits. Save on even ticks. Output both bytes on odd ticks. Both bytes. Well, alright. It's a little ambiguous as to what the phraseology means. I'm trying to assume save on even tick, output both bytes on odd ticks. Well, your odd ticks are going to be characterized somewhat obviously by the low bit here. So 0, I want to save a byte. 1, I want to save another byte. So let's hook you up. Pull all of you guys back a line, except you. Alright. Having difficulty selecting the ones I want. And put a knot in here. Right. So, notionally, that should go save 0, save 1, output, save 0, save 1, output. Oof. Save the byte. Correct outputs were 1 and 98. 8 and 98. Why did I get... Save on even tick. Output both bytes on odd ticks. Save the byte. Correct. That's what's my tick number? 1. The correct outputs were 48 and 254. I've got 254 and 0. Why have you not output? What is going on? And you've got a high line there. Just didn't do it. I have a solid confusion. I must be misunderstanding what this means. So if save 218, that was good. How do I get 86 in here? Is there some ticky box I can sort out that picks up the second byte? Stuffs it in there. As soon as I hit that, right, 0 to 107. Right, tick 1. It's wrong. But I am both loading and saving. 155 and 107. Have I got these upside down? Is that the problem here? Entirely possible, I suppose. And it's just complaining in an unusual manner. Oh my, hello, how you doing there, Zuma? Yeah, Zoom de Moskva. Yeah, Zoom de Moskva. Blimey. People with lovely names this evening kicking off. Right, save the byte. 112 and 241. Oh, right. Oops, put that in the wrong line anyway. Derp. If I had got them back to front, that wouldn't have worked. 64 and 158. And I've got 0 and 158. Why haven't you written to the register? Maybe I don't need a register. Maybe I'm just being dim. Maybe I only need a register for the other one. Alright, okay, fine. I can dig it. So what we actually have here is a switch. So that actually incorporates a delay. Oh, I think I understand. I think I understand. Right. So, save byte, 96. Oh, hello. 2have is doing us a raid. 2have to roll. Hello, raiding types, including the Mr. 2have to roll. How was your stream, dear fellow? Hello, raiders. I am Duke Euphoria de Grin, RGB, KSC, Knight of the Living Dead and Transgalactic Megapope of Rotating Space. We are playing Turing Complete, which is a game in which you build your own computer mob from literally tiny little gates and parts. We start from the simplest of possible things all the way down at the bottom, the simplest of all possible things being a wire. We get slightly further into arrangements of AND gates and NAND gates and XORs and all these things and truth tables to produce the small components of a computer mob. And slightly further up the line, we have a very, very rudimentary processor, but that nonetheless can run a program in ROM. Slightly further up the line here, we have a program on our very rudimentary processor that can do fun things like solve a maze. Actually, let's solve it a little slower so that you can see what's going on with the little robot. There he is. Having a little fun look around, doing his maze thing, collecting gold coins. Oh, isn't that nice? However, we are beyond that now, beyond such simple things as simple processor architecture and ones and zeros and flickery numbers going across wires. We are building our second version processor architecture, and thus are now labouring over things. Create a device that saves the program on even ticks and outputs both bytes on odd ticks. Red Robin is here as well. Hello, hello. How are you? Are you having a fine and awesome time? Good to see you. Haven't seen you since the dawn of time, or, 20 minutes past or so. And to have to roll, if you have to go to the little streamer's room, do chill, do go do the thing. I understand the nature of raid and run. It has to be done. And Dimitri is here with us, a new chum. Hey, Dimitri. We got to do those 3 questions again because we have a new chum. Boff. Did I type it right? Dimitri, you are now one of us. You must answer these questions 3. Which part of the world do you come from? What continent is yours? Do you come from Antarctica? Tell me you come from Antarctica. I haven't tagged Antarctica yet. What should we feed you when you come to dinner? And what will you feed us when we come to dinner with you? That's the way of things. It's all about the dinner. Alrighty, so we've saved a byte. That's more like it. The problem was the delay on the register. That switch outputs the data immediately, whereas the register hung on to it for a tick before putting it out. Okay, that's the problem we had. Right, tick, tock, tick, tock, tick, tock, tick, tock. Lovely. Done. Ooh. Now the programmable memory component. Ooh. And unlock the level for wide instructions. Nice. Dimitri comes from London. London, mate? What, that London? Down in the smoke? Bloody hell. You make me a stir fry, British food, roast dinner. Bish bosh, shimmer shimmer. Done. Look at my wood. So what kind of roast? Big roast beef, Yorkshire puds, roasty taters, boilies. Oh, Crew Cheshire, says AJ. Oh, hang on, have we got another one? Another? Join us, AJ. Join us. You know you want to. Pork. Okay, so we're going for crackling and applesauce. I'm in. Yeah, I can go with that. Ooh. This is not for you. I'm definitely in for that. I'm now thinking, yeah. So a nice big block of roast pork, or possibly slow cooked. Sorry, I'm drooling now. Slow cooked barbecue pork. That would definitely go nicely. And AJ's coming in with an omelette and a good tikka masala. Ah, well, in which case you've got to come up to North London within rocks throwing distance of Cannons Park Tube is the Cannons Park Tandoori, which, in my not specially humble opinion, is a very, very fine Indian restaurant indeed, and will do you an absolutely gorgeous tikka masala, which will leave you sitting there thinking, damn, I have been fed food. Bring forth more. Yeah, we're doing it on purpose, no. We are just trying to make you drool gently, but then again, if you're looking at butts, you should be drooling gently anyway. Oh, yeah. Oh, Dimitri's got a really good overnight pork recipe you did for Mother Sunday. Nice. Well, if you're in Crewe, it's not too bad. You've got a fair amount of train to do to get down to the smoke, but how are you for Manchester there, AJ? Because the Curry Mile there, that's got some pretty heavy hitters. Overnight pork recipe. So we're talking a really tender, slow roast pork. Is this pork and pineapple? Is this, 40 minutes. That's not too bad. That's definitely within the range of a night out, isn't it? That's what we want. Okay. finally, it is time to start building the leg architecture. All right. Well, we're starting with our previous, what they called overture architecture. Oh, close above. Well, I'm going to start ripping up the floorboards, I suppose. Joy. See, that was the last level that Aliana got to. Okay, put the game down after that. Never got round to getting back to it. So now we are in virgin territory, or at least unmapped parts of the world. Fun times. Oh, a lot of gigs in Manchester, says AJ. So you'll know the Curry Mile already. Excellent. And there's you lot in the Netherlands with your stuff that I will lean closer in to read the tiny letters. Hagelslag. Hagelslag? Hagelslag? Hagelslag. It's not going to be Hagelslag, is it? Hagelslag? Stroopwafel. Stroopwafel. Too much time and money on the Curry Mile. Blasphemy. Possibly heresy. There is no such thing as too much money spent at the Curry Mile. Actually, there probably is. Oof. The leg architecture is a computer that takes 4 bytes per tick from the program. Okay, that's roughly where we're at. So we're into a 32-bit computer all of a sudden. First byte, opcode. Since many operations take 2 arguments, second and third byte are for arguments, and third byte, fourth byte, whatever, is for the result. Okie dokie. Opcode, A1, A2, result address. Nice. Now, these are still bytes. There's not a lot of room for manoeuvre. I'm saying it more accurately than what you normally hear. Oh, thank you very much. I have had some, shall we say, instruction from the more Netherlandy members of the chat who have been telling me about stroopwafels since the dawn of time. Oh, stayed in an Airbnb on the mile? Oh, dude. I wouldn't be able to get back in the door. I'd pop my Airbnb open, park up the bike, lob my helmet out, drop my jacket on the bed, go out for a curry, and that'd be it. I'd be done. I'd come back, it's like, poof, no, oh God, no. They'd have to open a window to winch me in. I'm not saying that's a bad thing, but... Okay. Right. So a certain amount of this is going to be ripping up the floorboards. Ooh. Create a new empty architecture. All right. Place a program block with 4 outputs. Place a counter, increment to 4, connect it to the program block, add 6 registers or custom components with registers. Why does it have to be 6? I don't want 6. I want 6 to 8, or a sensible number of registers. 6 is a silly number. Anyway, right. Click Edit Link Components on the program component to connect registers 0 to 5, connect the counter to 6 and the output to 7. Alrighty. Okay, right. Schematic icon. New schematic. Leg. Right. None of that. None of that. Okay, fine. What's that level screen? Shows the visuals of levels in the main campaign. Well, you can go over there. Programmable 250 level. Okay. 250 byte RAM. Okay. What are you? Give me some things. Load, save, address, and save value. I have concerns already. Ah, that's the one I actually want. Cool. Right, counter. Derp. There you go. Really doesn't matter, does it? You are just going to be straight in there, no mess, no fuss. And we want you to be outputting 4 bytes. Or, actually, let's give you a number we can actually use. Oh, good grief. Right, and you can sit off over there somewhere. On the screen, I don't know where you're going to go. You're going to round the edge. Right, so we've got an input and an output. What did it say we had to do? Keep up. Yeah, all of that. Place a program block with 4 outputs. Place a counter. Increment 4, set the program block. Add 6 registers or custom components with registers. 8-bit. Have we got register plus? Because I rather like the way those other registers work. Let's have these fellas. Alright. Oh, there we go. I have to lean in for Snow again. How would I pronounce Shrewin? Shrewin. Shrewin? Shrewin? Yeah, Shrewin. Not sure where to go with it, but that's roughly where I'd be pronouncing it. Well, oh my, is that bad? So I've got no idea anywhere where I might be on that one. I'm entirely wrong. Ah, well, fair enough. Is it one of these sneaky words that is just not... It was picked to be... Yeah, okay, it's like how you pronounce slough in English. So if I type that... Yeah, that's the word slough. It's a place. Yeah, and it's just like, what? It's like, oh. Well, that's fair enough in and on its own. And then, how do you pronounce tough? No idea how to explain ew, but it's pronounced as sk. Okay, cool. Okay. Okay, give me some clues as to how your ew might go. I mean, I presume there's no Q's in it. 6 registers. Edit link components on the program component. Connect registers 0 to 5. Is that this one? Link components. Oh god. Register 0. Go that one. That one. 1. No. 3. 4. 5. 6 to the input. Input? Oh, okay. What are you? Oh, 6 to counter to 6 and the output to 7. Derp. Counter to 6 and the output to 7. Do not know what those are doing, but no matter. Finally, in this level, the opcode is always 0. I mean, we add argument 1 and argument 2 and save the result to the destination. Alright, no cues. Oh, that's alright then. Give me a clue as to how you gotta go. Oh, Snow's gotta vanish. Sweet dreams, Snow. Catch you later. Have a lovely evening. Don't die. It's bad for you. Ha. The value of an argument or destination. Whoa. Right. Value for this level, the opcode is always 0. This means we add argument 1 and argument 2 and save the result to the destination. Alrighty, okay. Right. So this is our register block. And I'm sure it's lovely. These are our things. So we've got presumably an opcode. And we're starting with a white, even though I know it's not going to help. Opcode. What should we have? Now I'm going to have opcode in orange because I want opcode to be fairly butch looking. Parameters are going to be inputs. Yeah, I don't want to get my parameters 1 and 2 mixed up, but I may need to be routing them in the same general area. So you two are going to be parameters pink and grey. Oof. Yep, no dying. Very bad, yeah. But if Snow is a bad girl, do you spank? There's like, is there a certain amount of no biscuit, or rolled up newspaper? You don't have to answer that. It's just like, you know, one of those weird things you think like, where are we going with this? Sweet dreams, Snow. Have a lovely time. All right. And our destination or destinations are always outputs, and those are purple. Why? Don't ask me. Swapping back my glasses so I've got more colour perception in more areas. The green and red ones are brilliant for some things, but not great for others. The opcode is always 0. So this means we add argument 1 and argument 2 and save the results to the destination. Argument or destination refers to one of these places. Register 0, register 1, so we're using 3 bits accordingly. Alrighty. There's no real anything. Whoa. It's all surreal. Just you calling her a bad girl. Oh, well, fair enough. Okay. Next level, implement more opcodes and require a different ALU. Well, that's fine. So our opcode is always 0, so our numbers are going to go to an adder at some point, which will get replaced by an ALU. We need to wire up registers, like we did last time. Okay. Let me do that. Going to need one of these lads. Definitely at least a one of these lads. Possibly 2 of these lads, in fact. Right. Oh no, it's gone worse than that. We're going to need 3, aren't we? Yes. Okay. Registers can go down there. Right. Destination 2 and 1. Or do I do them? I don't know. Do I do this as input 1? Input 2 and destination? Either way, I'm also going to need some splitters. Splitter. That goes with each one of these. And I need a little more room. Okay. Yeah, we're going to do these the other way. Oh, come on. Oh, come on. Give me the damn thing. I think my shift key's malfunctioning. We can just do them on the level. Right. Yeah, my shift key is malfunctioning. Damn it. I like this keyboard. Maybe I've just got to be a little more butch with it. Like, oi, you shift key, do as you're fucking told. You slag. Oh, can't control destiny, says Snow. Yeah, it's true. We understand that the lack of destiny control is a thing pretty much built into humans, but you certainly have some control over your ability to, I don't know, for instance, not throw yourself out of windows. I understand that that's one thing that people are pretty good at. And what did I have in here? Purpley buns, yeah. Okay. Not everyone. Ooh, okay. So some people just, they don't get it. They don't have the won't throw myself out of a window then. It's a bit of a rough one. So. Right. Destination. Parameter 1, parameter 2. So I might actually need the registers over this side. So I've always got the outputs on there. That's the ones I want. I'm going to pretty much ignore the load button here. It's always going to come off that one. The save button, save value. Frick only knows where that's going to come from. There's going to be a sort of resultant data bus coming in from wherever. But essentially, well, number 6 is a counter, so that can go off there. And 7 is the input or output. La da 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 da. Register 0, 1, 2, 3, 4, 5. Number 6. La da da. Goes to the counter. That's over that way. And number 7, in this particular case, because it's the destination, goes to the output. Right. Tempted to move the output somewhere more conducive to this. So we're going to have our data bus somewhere. Have a different color. know why. Just seems like a good idea. Oops, missed. Try again. Okay. Sometimes the emotional pain is so great, people will do anything to make it stop. Yeah, right, that is a thing. Yeah, people get brain weasels. It's fucking rough. Evil doom occurs, and there's not a damn thing they can do about it. I wish I knew how to fix that kind of shit, but I don't. Ah, dear. Right. So this is going to be the input bus, and it's only ever going to have one value on it at once, because that's the way things happen. And that value is also going to be available to the counter. Not quite there though. Dear. Somewhere around here. Oh, well, that's annoying. Managed to weld those two together. We don't want that. Yeah, I'll just move all of this lot down. So I'm being very boring at the moment. Because I'm trying to put down some relatively neat foundations before things go absolutely squirrely, which I am 100% certain that they will at some point. Right, and that's my output line as well. Okay. So, right, this here is this green one is my data bus. Nice. This is my input. Hello, input. Well, this is going to be fun. Because each of these bunnies is going to have a switch on it. Hello, you. And switch just there. Yep. Not bothering with that. Going to use the always output. Or I could actually use the load on some of them, and then I wouldn't need the switch. But I'd still need the OR gate that I'm planning, and each one of them is going to need an OR gate for the pins off the top of that. Yeah, all right. We need some OR gates. Hello. Wow. Oh, look. What a surprise. I haven't got enough bloody room. Who'd have thought it? Right, all of you lot. This way. Down you come. Oh, come on. Here we are. I am trying to grab hold of you, you junction. And you.
Coffee.
Yeah, thank you. More coffee, definitely. Here we go. Nice. Also definitely needed. Right, I think this is going to have to be on the data bus as well, isn't it? Am I going to be doing inputs and outputs at the same time? Possibly. Yeah. Well, that's going to be a laugh. Okay. Right. OR gate for each one of these fellas. You get the feeling I might need a little more room for some of them. Oh well. Hey ho. Shuffle them about as and when. Probably should have put them all to one side. Does feel like that now. Let's move them sideways while we can. Well, that's gone horribly wrong, hasn't it? That's gone just manky. And I have these fairly well spaced out, I reckon. How about I just put one in and we clean it and shine it and see how much room we need for another one. I think possibly getting ahead of myself here. Right, so what do we need? We need an OR gate, and that's going to come in with a pink line and a grey line, and it's going to have blue line because I like it that way, and it's going to have purple line. Alrighty. Plenty of room to play with. Right, you come up here somewhere. Another one. Of course, now that's in the wrong place. So that's going to move back one. Or this is going to move forward one. And that's got to go with it. Oh, grief, can't just get rid of the lot of you. Put them in one by one as and when. So that's just going to get in the way. So that needs to be like that. Blue line. Pink line. Grey line. Clumsy. And purpley line. Right. Okay. So what do we have between these? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. delete. Control X. Move up. All right, purpley line. Pink line. Grey line. Why the grey lines are all 90 degrees and the pink lines have got little diagonals in, don't know, just feels good that way. That's how I like it. I might change them all later. Three, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8. I think that might be coincidental. 4, 5, 6, 7, 8. All right. Chunk. Blue lines. There we go. Pink lines. Send them on down. There we go. Doing nicely here. Not that one. That one. Oh, called. And grey lines coming in now. Oof. What a mess. So much easier to do this in software than it is to actually do it with bits of wire on a bloody circuit board, I tell you. Right. Green, data bus. And the input is going to come in here somewhere as well. You're going to have your own little OR gate. Where are you? There. Blue line for yourself. And more pinky and grey ones. Do the purpley ones in just a moment. 7 for the input and output. Whoosh. So because these are parameter 1 and 2, right, there we go. Okay. Purpley lines. One more. Ugh. Doesn't quite fit. Great. 2 more. 3 more. Look at that. Is that annoying or what? Is that just irritating? It's irritating me. I'm just going to change some of these. All straight lines now. All those lovely diagonals going away. None of that. You ruined it for yourself. This is why you can't have nice things. Okay. Okay. Bots is making everything straight for the moment. I mean, There might be some diagonally stuff to deal with in a little while. But right now, everything's all going to be 90-degree lines. And I'll compact it and diagonalify it and make it nice. Why not make everything gay instead? I'll put rainbow colours. I'm doing my best. Besides, it's not Pride Month. I don't have to rainbow wash everything this month. I'll be back with you in a little while with the colours. I will. Right. So, the counter could be an input or an output. Oh my. So I need a 3-input OR gate. Do I have one? Well, yes, I do. So somewhere around here, I reckon. Bit more yellow line. I'll move everything up a bit. Then there's room to play like that. Okay. And my data bus needs a line to the counter as well. And that can even go through the same slot. Lovely. Right. There. Okay. So the output is always going to be oh, mate, now my brain's fried. Parameter 1 is going to be one of my registers. Parameter 2 is going to be another one of my registers. But I honestly don't know which is going to happen. Except I know that my registers are lit up at that point. Maybe I'm just being dim here. Maybe all that parameter 1 and 2 wiring is just nonsense. And I did have it right earlier. So I need a parameter 1 data bus. And a parameter 2 data bus. And what I've all the bloody things together. Which is correct. But not necessary, because I could have, as I did before, come off this line here. Oh no. Oh no, I've ruined it. Yeah, that's absolute nonsense. I can delete all of that lot. Pants. Big, saggy, elasticated tartan pants. And the counter is much correct. And the input and output is fine. Ah, no. Damn it. I think I have actually screwed up there. Because what I want is on these red knobs at the bottom here, I want a switch for parameter 1 and another one for parameter 2, which is driven by a pink or grey line here. I don't need to worry about whether it's doing a load or not. So I can bin this OR gate, and I can leave it on there, it won't cause any difficulty. Modify the register plus to register ultra plus with 2 loads and 2 outputs. I probably could actually. Let's have a look in the guts of it. Let's have a look. No, hello. Component factory. Right. This is my register plus. And you are 8-bit switched output. Nice. Yeah. That's my register. What are you, a memory probe? Yeah. Right. Oh, you were deliberately up there to give it some height, were you? Okay. If you remember, you did it without any special components, just a register with 2 switched outputs. Yeah, I'm seeing the nature there as well. Yeah. 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 Okay. So load, save. So what are you? You're a 1-bit input. You're a 1-bit input as well. Label direction left, up, right, down. Oh my. How come you're square? Oh, because you're connected to a square one. All right. And you live in that square. Yeah. So yeah. Okay. So a load 1 and a load 2 and output 1 and output 2 and you always output. Nice. And D8 just had to do some tech support for a friend's piece of shit system over the phone. God, I hate tech support. Yep. I have briefly worked third line support, and some of the weird shit that people did. I mean, we're talking proper weird shit. Kind of thing where you think, whoa, did you actually use your cerebral cortex for any of this? I do not think so. Ooh, okay. How about that? Not too terrible. However, we're going to do this because we can. And this because we can. Not quite sure what's going on here. Something weird. Ah, that'll be it. Better. Okay. What do you reckon? A piece of shit and a point of sale system. Oh, well, you never know. A point of sale, piece of shit, it's always the same. So I have just changed that one. Ooh. Have I actually altered it? I was expecting to change for a new one. Okay. Oh well. Fine, that's probably broken some stuff in the past. These things happen. Right, where were we? What? Hang on. Ah. Okay. Back to the plot. All of this lot now so much simpler. Thank you very much for the good idea of rewiring this to have different inputs and outputs. Just so much easier to work with. Dual ported memory, who'd have thought it? Dual ported memory at the register level. I have no idea why that's going to happen. And is this a standard processor architecture? Do we need to hit the patent office? It's got to be pretty standard these days, hasn't it? Blast. Okay, so our registers are slightly cleverer than they were before. That's nice. Might have destroyed the overture. Almost certainly. Completely has. Farshaw, hello matey, how you doing? I think I've accidentally ruined some stuff. Partly because this is an annoying thing to work with. If I don't know, what do I do? Do I copy this lot and say schematic, new schematic? Edit. Smart register. Go away. Wow, that broke. Why do... So that one's got blocks all the way down. This one doesn't. I just move it down a tick. Yeah, alright, fine. Done. So back here again, register plus. We just delete that fella. Leave it back as it was. Right. Right, okay. Playing some IC and relay stuff. That's the kind of thing we're playing with, Farshaw. If I pop out here, what we are doing is working through a list of tutorials to build a working computer, starting from such esoteric components as a piece of wire, going via delightful things like AND gates and XOR gates. Got our NAND gates there. Working through wonderful things like a half adder. Adding bytes together, what's that? As a half adder, full adder. There we go, look at that. That one's going to hiss at you. And all the way up to what I hope I've just mended with a little luck. There we go, everything looks relatively sensible. A very, very rudimentary CPU architecture. I mean, embarrassingly rudimentary by now, because you know, we've moved on from such childish things. So now, trying to build a slightly more impressive piece of kit. And I am actually having difficulty navigating the bloody game. Oh, this one, this folder, come on, in here. Right, there we go. Right, so this lot get deleted and replaced with my shiny new smart registers, which I'll have to link up to the memory again. That shouldn't be too much of a problem. I'm a little concerned that they have round blocks on them. But hey. We'll see how they work. I'm a little annoyed I only get 5 of them as well, but hey. There will be a moment in the future where you need more than 8 addresses. You might consider a bit of space to place a few more decoders. Oh. Right. More than 8 addresses. You mean, like, you know, the decoders will be fatter rather than such, like, yeah. Right. There's my pink wire. Sweet dreams, Michael. Have a good evening. I'm delighted to have had you with us thus far. I hope you have lovely dreams of all manner of wonderful things, the like of which I will not speak of on a family stream. Okay. Oh, blimey. Do I want my input there? I don't really know. I don't really care. The input could go back over this side as well. Have input and output in roughly the same place. It shouldn't matter. Butts is going to go away. Snow's going to be here tomorrow, so plan to be well rested. I really would. It would be an awful shame if you two didn't have the energy to do things. Also stuff. Yeah, definitely things and stuff required. Set up registers, implement the add opcode. Alright, I don't really it's just gonna be an add opcode. It's gonna be 0. 8-bit. Come on, there we go. 8-bit add. Right, so you can live up there. What are we going to have? Pink and grey. Again, so all of you lot are going to be on pink. Yeah, and there we go. Okay, and all of the next lot of you are going to be on grey. All right. Nice. So you have done an add. It is good. Now, can I attach these two together? I'd be surprised, but you never know. Oh, short circuit does not say short circuit. Goodo. Right. So what happens next? Oh my, oh my. Right. We took it. What do we get? Did not work. Short circuited like a bastard. Yeah, not totally surprised actually. And register 0 should have 16, not 0. Well, okay. So that's a bunch of pants. How did I have to do this last time? I mean, I had... Where's it writing the result to? Because all of this lot's the input side data bus. am I having to put switches on everything that says you can't be an input and an output at the same time? Because counter acts like another register, so you also need 2 switched outputs for it. Do I? I'm being the dumb. Why? Why do I need switched outputs for my counter? Because I haven't actually added it to the data bus, have I? I haven't been able to. I haven't put it on the input side at all. What I have done, like a derp, is carefully wired my input sides here through an OR gate to the right end of the counter. Well, that's just not very clever. Wow. I think I might be losing what remains of my marbles. All right. Let's put those in, shall we? One here, one there. Now the data joins to the same one. I think we do need the counter in the ALU, because the way the thing spoke of it, you could be reading from the counter. So I could be saying, get parameter 1 from the counter, or parameter 2, could be either. Some kind of pissy lime green colour. If we can read from the counter, do we have to set it up just like a register? Yes, we do. Kind of have all of that gubbins here. Right, so here's our counter over here. The yellow's our write line. The green's a data bus line. The pissy yellowy green colour is data in from the counter. And we got 2 switches here to say parameter 1, parameter 2 from the counter onto the data lines to the ALU, which is up there. It's currently just an adder. What's twisting my melon right now is how to get that data back from the ALU into the register lines. I have a horrible feeling Although I don't know. See, this is now clearly pants as well. I know this is our output, so that's okay. And this is all pantsed. This is wrong. Our input needs to be treated very similarly to anything else. So this OR gate, whilst correct, yeah, I don't know whether my input on line 1 or line 2, as it were. So I need a similar rig there. La 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 la. La 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 la. Right. You lot can move back a bit. You can join on there. And I'll have some more extension of these lines down to be my input layer. That's my input. That's going to come in from here. And we're going to have some more pissy yellow because that's just what we're going to use. You're going to wake up the input. And just connect to the bus. The input is just another register. Yep. So it's all sitting in the line of just more registers. Which is now how I'm now starting to set it up. I'm doing it very slowly and suddenly aware that I am probably making mistakes. And that's not good. Right, grey line. Also to grey input. Pink line. Also to pink input. Resultant, switch the input on. All right. Oh, missed. Is that why that isn't working? So why am I not getting numbers? Why am I not getting an 8 on you guys? Well, whatever. Okay. So once this is my output, well, yeah, I do actually think I want all of these guys wired together. So that comes out of the ALU. Out of all the numbers on here, there should be one result. Alright, so if I stop it and then tick it, okay, cool. Samic's bust, but it's not short circuiting anymore. Register 0 should have value 16, not 0. Okay, so what are we saying? Well, there is a 16 in here. And it's sat on what I would consider the results bus. This is eating a write line. It says save. Why? Oh, why? Does register 16, register 0 not have a 16 in it? What's your problem here? So what do we got? So these are basically saying write to register 0, parameter 1 is the input, parameter 2 is the input. Looks correct. Maybe an error on the insides of the register. Yeah, I hate to say it, may well be. That's annoying. Well, let's have the lid open, have a look. Doesn't look like it. I don't know. Add 8 result, register 0. It looks good. Something looks correct. Maybe a bug, replace the register again. Yeah, possibly. Actually, hang on. Is this hooked up correctly? Yeah, that is hooked up correctly. Oh god, I will be miffed if it's like, oh sorry, you can't carry on anymore, program's bust. I shall be quite upset. Is the probe inside the register also connected correctly? Let's have a look. Possibly not. Ha ha ha! Ooh. And Asmodeus says, if you remember correctly, change the smart registers for the normal registers to pass this level. A bug with the smart registers. Ooh. Right, but I think I have a feeling Robin might be correct in that that wasn't connected right. Didn't look good. So let's try it again. There we go. It was that. Right. Oof. So the bug was essentially the register wasn't reporting its results, not that it wasn't getting it. Okay, so next tick. Tick, tick, tick. All right. Just wondering whether I want to move the counter down as another register down here and just send its data line back up rather than its write lines and everything, and have everything in a big long registry thing. Ooh, yep. Asmodeus is probably the thing. How far are we away from Skynet? Yes, quite a distance, actually. I think this thing can't even spell Skynet, so I wouldn't worry about it too much. In fact, I would be distinctly unconcerned from a Skynet-y point of view at this moment in time. Yeah. Right. Yeah, I think I'm going to move this counter down to there and repair the stuff accordingly. Because my output really only hooks in to the purple stuff. That's all it can do. Because it's an output. There's no possibility of it ever being an input. These guys could well be inputs if they were needed. In fact, they are being inputs at appropriate moments. So let's line you up nicely again. That's just color match, isn't it? No, it is not color match. All right. Counter, come here, mate. All this nonsense can go away. We'll sort that out in a sec. That spur can leave. You too. You as well. Okay. Right. And a bit more space between these fellas. And an OR gate. Yep, I know what I'm doing now. Alright, it can all be much the same because I don't need to worry about it anymore. It's all relatively sensible. Result line, much the same there. Move back and green comes down to join on. Actually should be there, shouldn't it? Okay, that's a little cleaner. Right. However, we do need... Oh, I've lost one. Destination to the counter. Yeah, that's why this ore gate wasn't there before. Oh no, yeah, alright, fine. It's the purpley line that matters here. Okay, run that back across. And there. And purple. And there. Nice. Or very nearly nice anyway. Getting there. Come on, there we are. And now the line back to the actual memory.
Well, would you look at that?
That's a little neater, isn't it? How do you reckon? I think it's pretty fine, Leroy. What do you think? One more bit to go, and that's here like that. Okay. That all there doesn't need to be there. Could even just be like this. Or is that less? Whatever. Don't know. Don't know. Does look nice and neat now. So all my registers, my counter, which is essentially a slightly mutated register, and my input, which is a slightly mutated register. Right. Okay, so everything seems to be running still. And it being 20 past midnight, I think I may well call it there. I'll have a brief peek at the next one. Implement the following opcodes: add, sub, and or not an XOR. That's not too troublesome. We've got most of the gates for them. Ooh. Oh dear, oh dear. The opcode not ignores the second argument. All right, that's fair enough. Not going to do it right now. See what I did there? But we've got room for a big old ALU in here. We've got 2 pins coming in. We've got a data bus coming out. Oof. Blimey. Let's see who we can do a bit of a raid into, because it's that time. It is time for the old raidy goodness. Who's chilling out and having an awesome time in the rest of the world? Mog! We're going to go see Mog again. I like Mog. Mog's lovely. She's very chilled, very relaxed. I would say that anybody who is not too happy with the old spidery goodness, the old eight-leggedy beasties, might want to look away, because she's doing a bit of a paint, and I suspect there's going to be a certain number of legs involved. Right, so let's try and get a decent hook through so I can spell properly. Hang on to your elbows. We're heading out. For sure, thank you so much for the little hearts. I like them. I love you too. We shall see you lovely people soon, one way or t'other. I may be back tomorrow to lift the lid on some Stationeers code changes. I might decide to rampage a little more through this, because frankly I'm enjoying this one. Get back to Stationeers as and when. We'll be back hopefully Sunday. The moon units will ride again, and we will cause trouble at that point, if not before. Catch you soon. Hitting the button, banging out. Actually, before we do that, let's say thank you to some chums, because we can. Who has done us fun things this evening? We have had Dimitri following us. We've had to roll doing us a raid. Heinz Gustav has done us a follow, and Balls Pizza has raided as well. Balls appears to have raided twice, which is quite interesting. Not sure how that worked. We shall see you soon. We shall do fun things. I'm not quite sure where this computable Bob is going, but I do know it's going places. Have a lovely evening. Sweet dreams for those of you who are going to bed, and the rest of us, we're hitting Mog and the spiders. See you in a bit.